this video, we're going to go over forces and tension, which is a type of force, free body diagrams, and then finish with example problem number 12. Okay, so first of all, I want to talk about what tension is. Tension is the force usually in a rope or string. So I'll just draw a little example. So let's say you can see right there. Let's just say there's a box hanging from a string from a ceiling. Obviously, we can draw a free body diagram. So a free body diagram is where you draw all the forces. So obviously the box has the gravitational force mg all the way down. Let's just say the mass of this is m. Alright, so then the tension, to keep the tension of this, is also going to be mg, because this box is at rest, and pretty much what you have to do is to sum the forces. So if the box is at rest, the force of gravity is going to be canceled out by the tension because the box is at rest. So we could write that like this: sum of forces, and that would be equal to, you can usually write it like this: T sine theta minus whatever this is. So in this case it's mg, right? So, and it's T sine theta because there's only one of these. If there are multiple forces, we could do T1 sine theta plus T2 sine theta, and then minus mg. And if it's at rest, then it's going to be equal to 0, right? So here, obviously, we can just look, sine of this, it's vertical, so this is going to just cancel out, it's 1. So T, because this equation is equal to 0, T is going to have to be equal to mg. That's what tension will be. And usually tension, because there's something on both sides of the string, the tension is sometimes the tension is the same in both directions. So now we're going to go on to the example problem. Oh, and yeah, one more thing. In this, it helps to write free body diagrams and just draw out all the forces so you have a better idea where the tension is and which direction it is going in. So now we're going to go over problem number 12. A sphere of mass m hangs from the two strings that each make an angle of 30 with the horizontal as shown in the figure above. What is the tension of one of the strings? So we'll draw a little diagram right here, just like this, ball like this, both angles 30, 30. So we have T, those tensions are going to be the same angle, same length, and then this is mg. And the ball's at rest, so we know it's going to have to be equal to 0, so all we have to do is write a little sum of forces. So that's going to be 2t, because these are the same, and there's 2 of them, 2t sine theta minus mg equals 0. And now we know that sine theta is 30. Here I'll just make a quick note right here. Sine of 30 equals, we know that is 1/2. So now we'll put that in the equation. 2t times 1/2 minus mg equals 0. Now we can just simplify that. T minus mg equals 0. So our tension is going to have to be mg. Tension equals mg. Alright, yep. Now we look on our answer sheet. Number 12. Of course, we can look at it and we see there's answer choice D. And that's what you're going to circle, and that's correct.